Where does your passion for science come from?
Well, I was born in Boston, Massachusetts, in the United States, and I grew up in a household where science was very much a centerpiece, and that's because my father was a professor of physics at MIT. So he had 3 daughters, and it was important to him that we would be exposed to science and that we paid attention to our science classes when we were children. And at no point do I remember being told that I must be a scientist, but it was absolutely encouraged in our house. As for my choice of chemistry as a specialty, that did not really come to me until I was in college. And before that, I wasn't really fixed on science. I think I paid attention to the science courses because, again, in my family, there was an emphasis on that. But I had a lot of different interests, and I thought I might be a musician, as a career at some point. And it wasn't really until I was in college when I thought about biology as a major, and I thought about being a pre-med student, and go to medical school after graduation and so on. But I didn't give much thought to chemistry until I took a course in organic chemistry. And that was in my sophomore year of college, and that chemistry just changed my life. And I just fell in love with the subject. And I'll just never forget what it felt like to find a subject that I felt very passionate about. And I wanted to learn more and I wanted to study. Not because I cared about my grades at all, it was just because I really loved the subject.
Was there a particular person who influenced you?
I have had a few influential teachers and mentors over the years. I would say the first important science role model I had was my high school biology teacher, and her name was Margaret Schwartz. She's no longer with us, but she really turned me on to the field of biology. And then I would say the second important mentor was my organic chemistry professor. That was David Evans at Harvard University, who just passed away about less than 2 years ago, I think. And those two people really brought the subjects of biology and chemistry to life for me. And it's probably no accident that my own research career has been marked by the interface of chemistry and biology.
What do you enjoy about science?
Well, one of the elements of organic chemistry that hooked me on that subject was how visual the subject is. So understanding organic chemistry is all about understanding the structures of molecules, their shapes, how they interact with each other. And I'm a visual thinker. So for me, being able to understand a science discipline through vision was, I think, quite profound. And it's not hard to stay interested and curious in a field like organic chemistry, especially in the way that it intersects with biology, because there's so much we don't know about biology, about the natural world, including our own human bodies that we occupy every day. There's so much we don't understand about how our bodies work, and when things go wrong in our bodies, like what is wrong at the molecular scale. So we walk around every day in one of the great mysteries of life on the planet Earth. So there's always unanswered questions and puzzles to solve, and chemistry is a very powerful tool for doing that.
How do you cope with failure?
Well, I think a career in science inevitably teaches someone how to cope with failure. This is, science is, it's like all of the regular problems of life get amplified in science because you're inherently trying to understand the unknown. And you have hypotheses that often turn out incorrect. And the only way that you can find the truth is to do experiments and try and understand the data. And sometimes the data are not what you anticipated. So failure is a funny term because we use failure to describe events in life which sometimes it's not really a failure if you think about it at a higher level. For example, when my students come to me and they say, oh, I tried this experiment and it failed. And I'll say, well, why do you think it failed? Did you do a bad experiment? No, it was a thoughtful, good experiment. So why did it fail? And they'll say, well, because I wanted this to happen, but instead this happened. And then I'll remind them that's not really a failure. That's just an unexpected outcome from an experiment. That means you thought you understood what the outcome should be, but in fact it was different. That means that you have to rethink your hypothesis and you've learned something from that, quote, failure, unquote. So with that backdrop, I've certainly had events in my life that at the time I felt were obstacles, even failures. But in retrospect, they were learning experiences. And one of those was during my PhD years as a graduate student, when my thesis advisor, who was a young assistant professor at Berkeley at the time, unexpectedly was diagnosed with colon cancer. And when I say unexpectedly, it's because he was only 33 years old. It's just the last thing a person expects at that age. And so to deal with this illness, he ended up leaving his position. And his graduate students, such as myself and a few other folks, were on our own to finish our graduate work unsupervised. In the moment, this felt like a pretty big challenge and also quite risky. In retrospect, I learned how to run my own research project. I learned how to serve as a mentor to the other students in the lab who were younger than I was. And I just learned how to basically manage a research lab. This turned out to be a wonderful experience later when I started my own lab as a professor. But at the time I was a graduate student, it did not really feel like an opportunity. It just felt like a crisis.
As a woman in science and a member of the LGBTQ+ community, what barriers have you faced?
People often ask me if, as a woman in science or as an LGBTQ person in science, whether I've faced adversity specific to those categories. And it's hard to know as an individual what, types of, adversarial events I might have encountered because you never can really do the control experiment, right? So I don't know what my experience would have been had I been male or had I not been a queer person. I can say that being a minoritized person in science has its challenges, regardless of the minority group. When I was a student, there were people who were actively hostile to women in chemistry in particular. Organic chemistry also has a historical culture that was not particularly welcoming of women. And when I was a PhD student, women were a minority. Maybe 1 out of 10 graduate students in my program was female. I was the only woman in my lab. Most women were the only woman in their labs. And I noticed actually that it was challenging for these women because the men in our labs often looked at the women as dating prospects. And the interesting thing is the men did not look at me as a dating prospect because I'm a gay person. And I found actually that was of benefit to me because the men didn't really know how to talk to me and think about me. And so without any better idea, they just interacted with me like a chemist or like a scientist. So in fact, I think that was a benefit, whereas the women that they might have thought of as a dating prospect was less likely to be thought of as a scientist, first and foremost. So it might have actually been an advantage for me, since I was already minoritized as a woman, to actually be a gay woman. I don't know for sure, it's just a hypothesis.
Why is diversity of all kinds important in science?
Diversity is important in any setting where people need to solve complex problems and where people need to think creatively. So chemistry is a very creative endeavor. It's very important that we have diverse voices, mindsets, people with different ways of approaching problems around the table when we're trying to solve these important scientific problems. There's social science that's been done to quantify these benefits, and so that's wonderful. But it really seems common sense that you would want to have as many different voices and as many different opinions as possible when you're trying to solve a problem. So I've benefited in my own research from having a diverse lab of coworkers. Right from the outset of my independent career, I've had very good gender balance in my lab, and I've worked to recruit people from other underrepresented groups, people who might have historically been excluded from the sciences. In the United States, this might be people of color, also people who are gay identifying or queer identifying. And my lab has always been known as a welcoming place for folks who might think of themselves as being kind of minoritized. And I always thought that this was my not so hidden superpower. And people have asked me many times over the years, what was the recipe for success, for you in your lab? And it was very simple. It was diversity. And now I think being recognized with a Nobel Prize is the best validation I could ever have to reflect on the power of that diversity.
How can you create an open and accepting work environment?
It's actually not hard to create a work environment that's welcoming to a diverse group of people. It takes attention, and it takes good listening skills, and communication is very important because you're bringing people together who might not have had experience communicating with one another before. So just making it clear from the outset that this is a guiding philosophy of my lab. People who work in my lab have to understand that these are my values and these are the values of our lab. And then when friction arises, which inevitably it does when you have different people working together, there will always be some friction, but that friction can be translated into creative energy. And it's a matter of fostering open communication, being a very open person myself, making it clear to people in my lab that it's a safe environment for them to communicate with me, even if they're communicating things that are difficult for me to hear. Being willing to accept criticism in a constructive way. And these are skills that I think people should develop anyways, just to be successful, productive people in the world and impactful people. And it can start in my lab. But it's been a process for me, opening up my lab in a way that makes people feel welcome to come in, even if no one else looks like them. And I think there's always room for improvement, and I've gotten better at it over the years, and I'm sure I'll continue to improve. But it's been very worthwhile and rewarding.
How can we encourage more diversity in science?
Well, I don't know that I'm more qualified than anyone else to give this kind of advice when it comes to, promoting participation in science. But I do think it's wonderful for younger children, school children, for example, to be able to see scientists who look like them. I think representation is very important in how we envision the possibilities for ourselves. So for a young person to see women who are successful scientists, for a person who is coming into their own gender identity or identity around their sexual orientation, I think it's also very helpful to be able to see role models, especially since those people are stigmatized in many geographies, less so in the United States than, when I was born 56 years ago, but still, that's an identity that comes with a lot of risk in different geographies. And so just to be able to see a person who's comfortable in their own skin and has found a way to lead a successful and fulfilling life, I think this could be really profound. And then, just existing as a scientist is not enough for me. I think it's also important to be able to reach out and to communicate with people, who are younger and thinking about their future. And then to demystify what it means to be a scientist. I think if you look at the public images of scientists, whether it's in Hollywood films or television, scientists are often painted as extreme personalities, and usually male personalities, who are just different from the rest of us, either smarter than the rest of us or weirder than the rest of us, or both. And the truth, of course, is that scientists, they are the rest of us. And there's nothing really different about a scientist from a non-scientist other than a choice they made about their career, But otherwise, I think it's great if regular scientists that are not in the movies, not characters on TV, but real people, can take the time to get to know people who might have a misconception about a scientist. I've noticed that things that I say seem now to have more gravity, even though they haven't changed at all. I've always said the same things. But for example, the day after the Nobel Prize announcement, my university had an event, and they wanted me to get up and say a few words about the prize, and so I did. It was very spontaneous. I didn't script this at all. And someone had a cell phone video recording, and they posted a clip on Twitter, and it was about a 1-minute clip where I talked about the diversity of my lab and how that diversity created a culture in which we felt liberated to think outside the box and try crazy things. And that tweet just went viral. I mean, there were thousands and thousands of likes and retweets and so on, comments. And I realized when I read the comments on that tweet, and it wasn't my tweet, it was a tweet from the person who took the video, and I was reading through the comments and I realized that there was an appetite out there for someone to say these words. And lots of people have said words just like this, and I have said words like this myself. For decades, I've been saying the same thing. But now I'm a Nobel laureate, so it just gave so much more credibility to the idea. And watching that tweet and watching the comments from that tweet, it really sunk in that it's a platform, when you have a Nobel Prize.
What advice would you give to young women or people of minority backgrounds?
Well, for people who don't see themselves represented in mainstream science, and so that would be women and also people from underrepresented minority backgrounds. For those folks, first of all, I will say, when I was young, I did not see myself represented. I did not see successful women scientists who were decades older than me. There just weren't enough for me to find them. And I certainly had no view of openly gay people as scientists or in any career, really, because I came of age at a time when there was so much risk involved in being out that people stayed in the closet. So I know what it feels like to feel like you could never belong in a place. And then what happened was, a few people here and there opened the doors for me. And I had the great benefit of being born into a family where science was encouraged. And so I didn't grow up thinking I couldn't be a scientist. It was only later that I worried about whether I would find my way. So for a young person who's trying to figure out how they would pursue this career path, even though not many people look like them, I will say, first of all, now that we live in a globally connected world, where people can get on the internet and find information they couldn't have found in their backyard, you can find the role models you're looking for. They are out there. You just might have to look a little harder than the room you walk into. So take the time to look online and do your research and find out who are the scientists that remind you of yourself. They're definitely there, first of all. Second of all, find your advocates. So somewhere along the way, all of us had a handful of people who stood up for us. And if you can find a few of those people, they might be family members, they might be school teachers, maybe a neighbor even, or maybe someone they meet at an event sponsored by the Nobel Foundation, right? If you can find just a few people, that can really help your confidence, I think. And then finally, as hard as it might feel to break into an environment where you feel you don't belong, there will be a chance for you to pay it forward. And you might not find a lot of people in your own generation, but if you pay it forward, there'll be a next generation that follows you that will be larger, more robust, and more energized. And it's worth it, I think, to stick to your dream, even if it means you're more paying it forward than paying it back.
What advice would you give to a student or young researcher?
The one piece of advice I would prioritize for a young up-and-coming researcher would be, I would want to share with them how a life in science is incredibly rewarding. It's rewarding because it's creative. So you're discovering knowledge and gifting that to humanity for all of posterity. Because once you learn something, no one can take that away, right? It's not an object. It's an intellectual currency that will be shared throughout the generations. And you created that, right? And it has a permanence that, ironically, a physical object doesn't have. You can paint a painting. Eventually, it will fade, right? But knowledge doesn't fade. Knowledge stays with us forever, and it becomes the foundation for the next generation. So that's really exciting. That alone, I think, makes it worth it to become a scientist. But then on top of that, you have a lot of autonomy. And that's something I have always valued. Just the idea that I can govern my own activities, that I can pursue my own ideas and my own interests. And there's boundary conditions around it, of course, because someone has to pay for it, and I have to convince them to pay for it and so on. But I have so much autonomy in what I do with science. Very few professions offer that kind of autonomy. That's another great benefit of science.
What qualities do you need to be a successful scientist?
The most important quality of a successful scientist, based on the people I've known, is resilience. So that's the quality where you might be frustrated, you might feel like you just lost the game, but you dust yourself off, you get back up there, and you go out the next day and try again. And science requires a lot of trial and error, and there's a lot of confusion and frustration, but then you win a few. And when you actually have clarity on the science that you're studying, when you feel you understand it and it works as you had anticipated, nothing is more rewarding than that.
Do you enjoy teaching?
I've always had a strong affinity for teaching. I discovered that actually during my undergraduate days when, as a senior, I served as a teaching assistant for the introductory organic chemistry class. And what was so fun about that was I got to teach the students who were basically the equivalents of myself when I discovered my passion for the subject. And I remember how it felt when I took the class and how I fell in love with it. And when I taught that class a few years later, I wanted to create that magic for my students. And, you know, every once in a while, a student that I was teaching would have the same experience that I remember having. And they would come up to me after class and say, you know, I'm a pre-med or a biology major, but I had no idea organic chemistry was so fascinating. I want to switch my major. I want to become an organic chemist. And I thought, yeah, you know, I recognize that feeling. And so even now, you know, and I've been teaching for 30 years or so, but I still teach that introductory organic chemistry class from time to time. And every time I teach that class, I try to bring back the magic that I remember when I took the class from Professor Evans at Harvard. So that's part of the fun of teaching, is just reliving the magic, you know. And then, of course, the students even the students that don't embrace the subject as a calling the way I did, I know in my heart that I have given them a foundation that will help them with whatever they try to do next, whether it's medicine or science or something totally outside. I still think having, taken on the challenge of organic chemistry and having learned what many people feel is a difficult subject, I think is really enhancing for them intellectually. When you teach a class, you always learn something, even if it's a very rudimentary class, a very introductory level class. I always learn something new when I'm teaching. I'm preparing the lectures and I'm trying to find real world examples of that topic, and then I'm reading the news and learning some interesting recent story that I wouldn't have necessarily bothered to pay attention to otherwise. But I actually have a very specific story about teaching which relates to the Nobel Prize, which is at the time that we were trying to develop a new bioorthogonal reaction, and we were trying to figure out how to get azides and alkynes to react with each other with very fast kinetics. And the other Nobel laureates who share the prize with me were able to accomplish that with a copper catalyst. But for our applications, for bioorthogonal chemistry, that was not going to be useful because the copper catalyst was toxic to cells, and we were trying to do chemistry in cells and in animals. So we needed an alternative, and I was teaching organic chemistry that semester, and I was working on a lecture for the next day, which was on the subject of ring strain. And ring strain is a very foundational concept in organic chemistry that I had taught about every year for decades. But until that moment, it had not occurred to me that ring strain was a concept we could use to get this bioorthogonal reaction to work. And it all kind of came together when I was writing that lecture. And so the next day, I taught my class, I gave that lecture, and then I talked to my grad students and said, go see if ring strain will solve this problem, and it did.
What are your interests outside of science?
I've always loved music. My parents, my mother, signed myself and my sisters up for piano lessons when we were, 6 years old or something. So I played the piano all through childhood, and then in high school, I had an amazing music teacher named Sandy Peasley in Lexington High School. And she introduced me to jazz, which was amazing because that's a very creative form of music. So I played in jazz bands throughout high school. And on the side, I would play rock and roll and pop music just for fun by myself. But when I went to college, I got involved in a freshman band. I met a drummer who lived in the same dorm, and we started this band, and we weren't very good. But one of our gigs was at a local college party, and another Harvard student was there, and he heard our band play. And he was starting his own band, and he was an amazing musician. And this person is Tom Morello. And Tom was 2 years ahead of me in college, and he recruited me to join his band. And the name of our band was Board of Education, B-O-R-E-D. We thought that was quite clever at the time. And we played that year in this band, and we won the Battle of the Bands. And we played some of his original compositions. People will recognize Tom Morello's name because he went on to become a very famous rock musician. He formed a band called Rage Against the Machine, which was an award-winning heavy metal band. And then later he formed a second band called Audioslave. And right now he still performs with Rage. I think they're back together touring. And he also does solo, unplugged recordings, and he plays with other bands. He's very famous, very well known. And at the time, I think you could have predicted it because he was a phenomenal musician even when he was just 19 years old. I still play the piano by myself with my headset on late at night as a relaxation activity. From time to time, I wonder whether I could convince some other professors to get together and form a band with me because there's actually a lot of musical talent in the academic science world. And in my own department at Stanford, we have a drummer and a bass player and a guitar player, so nothing stops us other than time.
How else do you like to spend your free time?
I don't have a lot of free time, but I do try to make an effort to go to the gym. I'm an avid weightlifter, and I've taught myself basketball during COVID because that was an outdoor sport, when all the fitness centers were closed. So I try to shoot hoops a couple times a week if I can. But any sport with a ball, I will try and probably have fun doing.
How did you find out about the Nobel Prize?
Well, the chair of the chemistry committee called me and woke me up. And so I found out, at 1:43 a.m., I took a screenshot from my cell phone because I couldn't believe it. I said, I'm going to take a screenshot and then I'm going to wait 10 minutes and then see if it's still there. And it was. So I found out the way that everybody finds out, with crazy phone calls in the middle of the night. And then there was the live stream, which I watched online and was on standby on the phone. And then the doorbell rang, and it was the media relations people from Stanford University who were just ready to go. Came into my place and set up shop and arranged interviews for the next 12 straight hours, pretty much. So that was a pretty crazy few days.
What do you believe is the greatest benefit to humankind of your research?
Well, my research, as recognized by the Nobel Prize, was the invention of a field of chemistry that we call bioorthogonal chemistry. And we developed that chemistry so that a person could do a chemical reaction inside a biological system. And by that I mean chemical reactions in living cells or living animals or even living humans. And right now the most obvious benefit to humanity is in the form of new medicines and new ways of treating cancer. And so bioorthogonal chemistry has allowed people to build new kinds of pharmacological agents, new kinds of drugs that would be hard to build otherwise. And right now, there is a human clinical trial in which bioorthogonal chemistry is being performed inside the body of cancer patients in order to deliver a medicine to the cancer and spare the healthy tissues. So I think in the field of medicine is where the biggest impact is right now being felt.
How does it feel to see your work having an impact?
I'm delighted to see the work that came from my lab making the translation into new treatments for human disease. This was the dream of mine, from my early days as a new professor, was to do something, using my skills in organic chemistry that might benefit human health at some point. I didn't know whether that benefit would ever occur in my lifetime. A scientist rarely knows that. But now I've been working in this field long enough that I can see the possible new medicines that are coming from bioorthogonal chemistry, and I'm just delighted.